So we looked at this part a little bit in the slides. It's got a lot of different things going on in this part. You have an open pocket here on the back. You have multiple pockets in the middle. You have a step pocket here on the right with an island. You got a slot. You got chamfers on the slot. So you got a lot of things going on. Let's go ahead and do a facing operation, and we'll just go into 2 axis facing. And for this, for the standard facing operation, you do need to select geometry. So I'm just going to go ahead and just select. You can select the top outer edges or the bottom outer edges. If you on this part, you see you have an interruption there. So I'm just going to select the bottom edges. And for the tool, we can go ahead and use the face mill. And for the roughing area, we'll put stock at 0. We'll use a mixed cut direction. We're going to use an island offset cut, which means it's going to follow the perimeter of the part. The step over, we'll set that, say, to 40%. For cut levels, we're only going to take one level off. So the location of our geometry, and this is a good usage of the pick top. We don't want to cut down here, obviously, we want to cut up here. So we're going to say the top of the cut is right here. Let's set that. So that's the top of the cut, and I'm cutting down 0 depth. So that means it's going to make one pass at the pick top that I picked. So let's go ahead and do, you can also obviously control the entries and exits. So here is our facing operation for the top of the cut. Now you can also face off open pocket areas. So this you might think that, well, this is this is a pocket. Well, actually it's a face because it's a flat area and has an open area on the end. So we can use facing to define this. So let's go ahead and do a facing operation. For the control geometry, we're just going to select these edges. And then we're going to select a tool. Let's just use, say, an 1/8 inch. This is a small pocket area. And we're going to go stock. We'll leave that at 0. This is a finishing pass, so we'll just 1,000 for tolerance. A mixed cut direction, a step over of, say, 40%. And we can do a one or multiple cut levels. We're just going to do one cut level. Again, where is the geometry I selected? I selected at the bottom of the cut, so it's at bottom. And I'm going to do one cut level. So these, the total cut depth, and these are all 0. And the entry and exit, we can set it to none, or we can set it to lines and arcs. And let's go ahead and fit curves. And let's generate that. So here is your open-faced pocketing. And
so Don, one quick note on the open facing. You kind of picked it very quickly, and I just want to emphasize that. So what internally what this operation is doing is when it looks at this open curve in facing, it's actually putting a line segment from the end point to the start point of the curve. And it's saying that line segment is really where the material, the stock material starts. So that's how it figures out how to enter the material. That's why you're seeing the entry exits go through that line segment. So you can leave, you can use an open curve in facing, but internally we will add a line segment to close it up. So it's important, to know that. So
if you had just selected this side and this back side, let's say you stopped right here. Let's say you stopped there. Then the path would be calculated from here up to here. So it would stop along this theoretical line here. And a lot of people,
that might not actually work because you might have an intersection there.
But I mean, in general, if you have a open curve and it'll stop at each end, and as long as the geometry that you want to cut is within this area, that's how it would work. Okay, so let's see what else we got going here. Let's do some step pocketing. So let's go ahead and we'll do a 2.5 axis pocketing operation. And we have some predefined regions already set. Let's see what we got here. We've got that outer perimeter set, and we have this set. So let's use the outer perimeter as the control geometry. And for the tool, we'll go ahead and use a 1/4 inch tool, flat end mill. And for the, we'll go ahead and leave some stock, and we'll finish this off with a profiling operation. Let's just tighten this up. Well, 0-1 is fine since it's going to be a roughing operation. We do an offset cut pattern, a mixed cut direction. We're going to start on the inside of the pocket and work our way out. And we'll do a step over of 40%. And for our cut levels, we'll go ahead and do one cut level, and it will be at the cut where location of cut geometry is at top, because that's where our control region that we selected is. So for the total cut depth, if you don't know the depths, just pick this button and pick 2 points, and you can get a little bit in there. Pick a top point and a bottom point. It'll calculate the depth for you, and then you can divide it up into multiple cut depths. And this is the entry and exit. We'll just use a helical entry, and we'll do arc fitting. Let's see if it finds any arcs, and let's go ahead and generate that. So here let's go ahead and do this. Here is our cut levels right here. 2 cut levels. So the base of the pocket is here, our geometry is here, and this is the first cut level, and this is the second cut level.
Don, there was a question on arc fitting, and I just wanted to point out in this toolpath that Don's created and is being displayed on the graphics screen, you can see these dark blue lines. Those are arcs. They're fitted arcs, which are actually fitted after the toolpath is generated. So this can help you in improving the quality, surface quality, as well as the speed of machining, because you're taking a whole bunch of point-to-point moves and converting them to arcs.
Mm-hmm. Yep. Okay, we got some additional pockets. So let's go ahead and clone our first pocket. And we'll make a copy of it. And we're going to go ahead and remove all. And what we're going to do, we're going to select, we'll use select the flat area for here. And that'll be one area. And then also we can, okay, let's just do this area for now. And let's go to our, we also have an island here. So we're going to, now here's a neat trick. If you already have something in your control geometry list and you don't want to get rid of it, you just want to add to it. So just press the shift key and select the curve edge regions button, and you can pick another area. We'll just pick the top of this.
Don, when you pick the flat area, it would have automatically picked the inside too.
Yeah,
so
you're right.
You don't need that.
I'm already in the middle of it, so we'll just pick it. Okay, so same tool, everything else is the same. See, we got a offset cut pattern. Everything else is the same for our cut levels. We're going to clear the island tops. So we got an island here. So it'll put a cut level at the top of the island. That's what we mean when we refer to step pocketing. And for the depths, we can detect it from the part. And for the entry and exit, we'll leave all this set as it is. Oh, it looks like I already cut that. Let's take a look at this again.
The reason is you pick the flat area region and it automatically picks that top also.
Okay.
So
okay.
remove the flat area machining, flat area region, the first one. Where do you have that? Oh, you only picked that because,
Okay.
you need that. Yeah, you need to pick the outer one too.
Okay, so I just shift, and then I'm going to go here, and at the outer one. Yeah, it dropped my predefined region is what it was. I accidentally dropped it out of the selection. Okay, so if we look now at, you'll see that it put a cut level at the top of the island as well as down to the depth of the pocket itself. So that's what we mean by step pocketing. If you have islands in the middle, you can go ahead and add those to your control geometry selections and then select the option to clear. Let me just show you where that is again. Cut levels, clear island tops. So any flat areas, it'll put a toolpath right at that level to make sure that they're cleared. Okay, so we got pockets. Let's go ahead and do a finishing operation for the pockets themselves. We'll go to profiling and let's see what we have. We have that. Let's go ahead and use that for the top pocket. Same tool. And actually, let's go down and use a 1/8 tool for the finishing. And for the cut parameters, tolerance 1000, stock is 0, and mixed cut direction. And we're going to let it start at the midpoint of the longest side, which will probably be over here. And we will, for the cut side, you can use inside outside for closed curves and say you want to cut on the inside, or you could just pick determine using 3D model and it'll figure out which side to cut. And for the cut levels, the location of the geometry is at the top. And again, let's go ahead and select our depth. And we're just going to have a total cut depth of 0.333 and no finish depth. And same for the rough depth for cut, which means it's going to make one pass around the perimeter. The entry and exit will use a you can use a ramp, typically used in profiling, a ramp, or since we have an open area there, we can use lines and arcs, and we can pick none for the exit. And we're going to set the fit arcs and everything else. Let's go ahead and generate that. So we got a profiling operation that finishes this outer area. Let's go ahead and clone this. And we'll remove that. And let's go ahead and select a flat area. And same tool, everything is the same. So that puts a, well, you may not want that. So let's go ahead and change this to, so that probably would work. Or just pick the determine using 3D model. There we go. Here you may want to do a ramp motion if you want to see what the ramp motion looks like. Let's go to entry and exit. We'll do a long path, and the ramp height will be at ramp angle will be 10 degrees, and the height will be 0.05 above the part. So you'll see if you look at the you see that you have a ramp height and a ramp, it ramps down into the cut start point. Anybody have any questions on any of these, just let me know. I want to try to get through this part before we get done here. Okay, so what else do we got to do? We got a slot. Let's go ahead and create a slot, 2-axis and slotting. We'll go ahead and select this flat area for the slot control geometry. For the tool, we'll go ahead and use, I think a 1/4 inch will fit in there. Let's try it. And for the slot parameters, 1/1000ths, we're just going to finish this. So we're going to stock is going to be 0. And what we're going to do is, if you only had, this is a good point here, if you only had a curve and you didn't have the slot models, you could just use this option to treat the curve as a spine, which in other words, that would be the center of the slot. similar to engraving, where the tool would follow the curve at the tip of the center of the tool. Everything else looks pretty much okay. We have cut levels. The location of our geometry, we pick the bottom, so we're going to say at bottom, and we're going to pick the total cut depth. So here we'll pick a point on the top and a point on the bottom. So it's 25. We'll set that to 2 passes at 1/8 of an inch each. And the pocketing entry and exit, we'll just leave it at path, and let's generate this. So what you see here, if your tool is smaller than your slot width, it will automatically use a high-speed cut pattern, which is a tangential constant cutter engagement cut pattern.
It's actually called a trochoidal cut pattern. You might have heard that being used.
Yep. And so that's the area for our slot. Let's go ahead and do this chamfer. A lot of users ask and have trouble doing chamfers and filleting. So let's go ahead and do this chamfer. Your part model can have the chamfer modeled, or it doesn't. It doesn't matter. As long as you have an edge, this bottom edge right here, defined. If you have the chamfer defined, you can use the bottom edge of the chamfer. If there's no chamfer defined, you just use the top edge of the parts. Since we have the chamfer defined, we're going ahead and do a chamfering operation. And we're going to go ahead and we'll select our curves. Let's work our way around here. Okay. And for the tool, we're going to use our 45-degree V-mill. So this is a 45-degree chamfer. And for the cut parameters, so we're going to set a tool tip clearance. In other words, the tip of the tool will go past the depth to clean this bottom edge. So put, say, 10 thousandths. And the cut width is, we'll leave that set, I believe it is 0.01. I think, let's see, let's try that. And maximum cut depth, so it's going to cut it all in one depth since this value is larger than the width. And we'll use a mixed cut direction. We're going to cut on the, let it determine from the 3D model. We're not going to use a step over. And for the entry and exit, we'll just go ahead and do a long path. Use a none for the exit. We'll fit arcs. And let's go ahead and see what we got there. So here is our chamfering operation. You'll see that it is lower than the edge, so it's cutting the tooltip clearance. This is the tooltip clearance right here, and it's based on the edge. So if you didn't have a fillet model, you could just pick the top edge, and it'll figure out the depth and the tooltip clearance for you. Okay, so what else we got going on? We got a hole here. So let's go ahead. We got a few minutes left. Let's go ahead and do a hole pocket. So we're going to go through a hole pocketing, and we're going to use this edge, 2 edges here for the hole. For the tool, we'll use the 1/4 inch tool. For cut parameters, for hole pocketing, where's the cut geometry? It's at the top of our cut, so we'll leave it at top. Calculate the depth, and it's at 0.33. We'll set that to a step down, let's say 0.16, say. That'll make it 2 levels. And we can do a cleanup pass, which means it's going to cut 1 level, work its way out, and then do a cleanup pass on the outer perimeter. Step over, make it 40%. For entry and exit, for hole pocketing, the entry and exit is a helical motion. So you're defining the height or the angle of the helix. So we're going to leave this set to this height of, say, 0.01 or 0.1. And well, that's it. Let's go ahead and generate that. So let's look at so we have a hole pocket, 3 cut levels. Each cut level has a helical entry and a cleanup pass at each cut level. So the blue is a circular motion at each cut level to clean that whole pocket up. Let's see what else we got in here. Joe, do we have any questions? Do we need to reserve the last 5 for questions?
No, go ahead.
Okay.
Finish up the demo.
Okay. So what else do we got here? I think all we need is do the outer perimeter, and then we'll do a simulation to see how it looks. So we're going to do a profiling. We're going to use this outer edge here, the same curves we use for the facing. And we're just going to clean this up on the outside. So for the tool, we can use our large flat 1/2-inch end mill, cut parameters, tolerance, stock is 0, mixed cut direction, use midpoint of the longest side. For the start point, we'll determine based on the 3D model. And for the cut levels, the location of cut geometry is at the bottom. Our total cut depth, we're going to pick 2 points, is 1, and we'll set this to 4 cut levels. And entry and exit, we'll just leave that as a long path. Lines and arcs. Lines and arcs, we'll use a radial entry exit and a radial entry. Advanced cut parameters, we don't have any arcs, so we don't really need this. So let's turn that off. We do have some cornering options that would work good here. If you don't want, a lot of cases, you don't want the tool to roll around this corner. So we're going to make it a sharp corner where the tool will go past it before it goes in the next direction. So let's go ahead and generate that. So there's our profiling operation with nice square corners. So let's go ahead and do a simulation. And we will, let's make sure we see all of this. So let's go ahead and make this up a little bit. Let's go ahead and check some preferences. Okay, we'll set it fine. Opaque, that's good. Let's go ahead and play this. Now, the reason you don't see any stock removal there is because the stock is exact the height of the part. If you want to actually see the stock removal, you can increase the height of the stock and cut that. We can go ahead and do that. Let's put this at 0.1, say, and then make sure the stock is aligned with the bottom. Click OK. Okay, and then we'll run this again. So there's our facing operation. We have our second facing operation on the back side. Slow this down a little bit. See if we can slow this down a lot more. Okay, and that's our second facing operation on the outer side. So let's do our pockets. Just speed this up a little bit. If you don't want to wait, you can hit pause and to end, and then turn the toolpath off to see your pocket. Let's do the next pocket. This will be the step pocket. Okay. You'll see that it put a level at the top of the boss area. Let's turn this off. And this is a roughing. Remember, this is a roughing operation, so it leaves material on the sidewalls. So we'll go ahead and do our profiling. That's the finished profile for the top pocket. Finished profile for the bottom. Let's see, we didn't clear all that. Looks like we got a problem there on that one. Let's take a look at this. Let's do cut levels. Okay, let's pick that bottom. Let's resimulate that. Okay, that's right. So we got cleanup finishing passes for the island and the pocket. Let's go ahead and do our slotting. So you'll see what it did. It made 2 cut levels, and it also made a cleanup pass at each level. So there's our slot. For our chamfer, let's slow this, see if we can't slow this way down here. Okay, so let's get in here a little bit more closer and run that again. And if you want to see the tooltip clearance, let's go ahead and open this. Let's go to there and let's look at this. And let's run through the paths here. To look like I see it here. Let's change the preferences here. Okay, and let's go ahead and step through it. So if you look right there, there's the geometry we selected as the bottom edge of the chamfer. Our tooltip is going down past the chamfer. And let's go ahead and play that. Working its way around. Okay, let's see what else we got here. Let's turn this off. Let's turn our preferences back. And we got the whole pocketing. So there's our through hole and profiling. Nice square corners. That's really important to use that. That's a very good enhancement we recently added. If you're cutting any type of cutouts that you want a square corner, you don't want that tool to roll around it because it will degrade that corner. So using the sharp option on the profiling, it goes right past the edge before it changes direction. We got any questions, Joe? Looks like we're right at the cutoff mark.
Yeah, I think we're good, Don. That was a good demo.
Okay, we've got some other parts that go with this. If you want the parts, just send us an email, and we've got parts for the regions and all the other things that we talked about besides this part, and we can send them out to you. Okay, if you guys have any more questions, just send us an email, and we will make sure we respond to each of those. And we hope you enjoyed today's webinar. And y'all have a good day. Take care.
All right. Take care. Thank you very much. Bye-bye.
Bye.